My name is Krishnan. Today I'm going to explain about my third experiment, which is controlling looping statements in shell programming. So our first experiment is um, uh, about palindrome, which is so we'll see the program for the palindrome. So first we'll ask the user to enter a string to be entered. Then the string is read. So after that we'll check the length of the string, and the length is subtracted by 1, and it is stored in len, where while we'll test that I is less than j. If I less than j, we'll assign k as string cut minus c. After that, L is assigned as string cut less than length. If the test is k less than equal to the 1, then the string is not palindrome, or else the string is palindrome. So we'll execute this. After that, we'll ask the user to enter string as we'll enter string as uh, mom, where it is so we can say that this program is executing properly. After that, we'll go to our next experiment, which is we'll see the Fibonacci series program. Fibonacci series program. This is the code for the Fibonacci series program, where we'll ask the user to enter the number of terms to be generated, and n is assigned as the number of terms, and we'll initialize as x is equal to 0, y is equal to 1, and I is equal to 2. After that, we'll print that Fibonacci series up to n terms, where we'll print the value of x and y. While I is less than n, we'll increment the I value as +1 and z value as x plus y, where then the z is printed. Then we'll assign x is equal to y and y is equal to s, where swapping is done. Now we'll execute this program. The number of terms that we have to generate, let's take 5. So we can see that 5 terms of Fibonacci series is printed. After that, we'll see the program for the Armstrong number. This is the code for the Armstrong number program, where we'll enter a number and we'll read that number. After that, we'll assign x is equals to the number, as we'll assign sum r and n is equal to 0. While x is greater than 0, then we'll assign r as x modulus of 10, and n as r into r, where sum is equal to sum plus the number of terms, where x is equals to x of x divided by 10. If the sum is equal to c, then we'll print it is an Armstrong number, or else we'll print as it is not an Armstrong number. Now we'll execute this program. Enter a number, Armstrong number. You can say that 153 is an Armstrong number. So we can say this program is working properly. Now our fourth experiment. Fourth experiment is uh, fourth experiment is of prime numbers. Prime numbers. So we can see this is the program for the prime numbers, where we have to enter the starting range of that number, and it is read, and this ending range, and it is read by the program compiler, and we'll assign c is equal to 0, where echo prime numbers are, we use a for loop from a to less than b and incrementing I. After that we'll use a for loop where j is initialized to 1 and j is less than I and j is incremented, where we'll assign x is equals to I modulus of j. If x is equal to 0, then we'll assign c is equals to c plus 1, else if c is equals to 1, then we'll print I, and this is the program for the prime numbers. So we'll execute this program. We'll enter a starting range which is 50, and another ending range is 100. So we can see that it is generating the prime numbers from the range 50 to 100. After that we'll see the program for ascending and descending order. For ascending and descending order, this is the program for ascending and descending order, where we enter the number of numbers, elements you have to enter, and it is read. After that, we have to enter the number of elements. Then we use the for loop uh, to initialize the elements, where I is initialized to 0 till less than n, and I is incremented, where we'll read where we'll read the a of I array, where we'll print ascending. For ascending, we'll initialize a for loop where it is it is for I is initialized to 1 to n, and I is incremented every time. And for the second for loop, j is equal to 0 till n is minus 1, j is incremented every time. If the if a of j is greater than a of I, then we use the swapping. Then for loop is used from 0 to I n, and we'll print one by one the elements. For descending, we'll use a for loop where we'll see that a of j is less than a of I. Then we'll do the swapping, where after that, where for loop is used for printing the array elements. So we'll execute this program. We have to enter the number of elements, which is 5, and which is 4, 7, 9, 2, 1. And we can see the ascending order is 1, 2, 4, 7, 9, and descending as 9, 7, 4, 2, 1. This is the third experiment for the UNIX lab. Thank you for watching this.